All right, so let's take a look at 47 here. Because 47 and 49 are very similar. So once I do 47, you guys should be, if you had troubles, you should be able to do 49 yourself. All right, so 47 said, I have 4m to the 4th. So after I talked to you, did you try and do it yourself? Okay. Okay. So tell me when I'm writing this down, what don't you understand? This is not the distributive property. Just because there's parentheses here does not mean this is distributive property. I don't know if that's what you're thinking about. This is not the distributive property. So what function, you guys, do these parentheses hold? And are they necessary? What function do they hold and are they necessary? Sophia? They're not necessary. All they're doing is they are just indicating I need to multiply this term by this term. That's all it's saying. Multiply 4m to the 4th times n to the 7th times m. But in reality, what is the only operation going on here between these variables and this number? Coral? Multiplication. If I was to rewrite this, this is just m4 times m to the 4th times n to the 7th times m. I could simply write it that way. Those parentheses don't mean anything other than we're multiplying. If there was addition between the n to the 7th and the m, that would be the distributive property, and then this would be a much different problem. But that's not, and we're not going to have those, right? This is all just multiplication. So now I'm just going to move the variables next to each other that are the same, just like I did in all the other ones. And now I'm going to use my power rule because I have m to the 4th times m to the 1. So this is 4 times m to the 4 plus 1 times n to the 7th, which gives me 4m to the 5th n to the 7th. Everyone's looking at your work, and you're looking to see, other than rewriting it this way, you didn't have to rewrite it without the parentheses, all of this you all should have. Does that help you? So you should be able to do 49 now yourself to practice if you understand it right. Okay. What else can I do for you guys? Matthew? All right. We'll take a look at 61. 61 said, I have negative 5 times a to the 7th times negative 4 times a squared. Again, what function do these parentheses carry? Cullen? Just multiplication. Why do you suppose they use parentheses to show multiplication between these two variable terms? Why do you suppose they use parentheses? Addie? Yeah, I mean, if I just use a dot there, we might miss the dot and think that this was subtraction, right? How many of you guys, Patrick, can see that that could be that could be a big mistake, right? That if I just use a dot, we might lose the dot and think this is subtraction. So that's the function of the parentheses. So anytime you guys see parentheses, don't just assume that we have the distributive property. Really take a look at it and say, okay, what operations really are going on here? This is simply all multiplication. This says negative 5 times 7 times negative 4 times, negative 5 times a to the 7th times negative 4 times a to the 2nd. So I'm just going to move, Matthew, all of those numbers that I can, in terms that I can actually multiply together next to each other. And again, I just use multiplication to show multiplication. There's parentheses to show multiplication. Between the variables, I really didn't need to, but I just did. All right, so now I can multiply. Negative 5 times negative 4 is a positive 20. A to the 7th times a to the 5th. Remember, this only was when we have multiplication. A to the 7th times a to the 2nd is a to the 7 plus 2, which gives me 20a to the 9th. If there are other ones that are similar to these that I've just done that you did not understand, now that I've gone through a couple of them that have parentheses in them, I want you to do them on your own to make sure you guys get it. Oh, you switched, okay. All right, put this away, get your notes out. We need to talk about division power rule. All right, so what I would recommend is tonight to add to your homework a little. If there are some that you guys did have troubles with, and we've gone over a couple of them already in class, I highly recommend you do one more from last night. So if 61 gave you troubles, and we did 61, now go back to 60 and make sure you understand how to do 60. Or maybe go back to 49, which also had parentheses in it, and make sure you understand how to do 49. Redo some of them now that we went over them to reinforce in your head that you understand it, and then do tonight's homework. That's what I would recommend for you all. All right, today is the 4th. All right, we are still in 4.5, so 4.5 continued. And today we're going to talk about division power rules. Division power rule. All right, so let's review our addition power rule. I'm sorry, our multiplication power rule. Just so we kind of have them on the same page. This is our first power rule. This is when we are multiplying two or more. I say numbers, but it's like terms. I'm going to say numbers because they could be variables. I'm going to put a parentheses variables with the same base. All right, so I have a to the m times a to the n. All right, we keep the base. We add the exponents. So it would be a to the m plus n. So there is our first power rule. This is what we did last night. All right, this is our second power rule. I'm not going to put 2 there yet because I want to number the actual rule. This is our division power rule. It's the same idea, but it's only going to be 2. This is when we are dividing two numbers. I'm going to put in parentheses variables with the same base. All right, this is when we use our division power rule, when we're dividing two numbers or two variables with the same base. All right, I'm going to explain to you how this works, and then I'm going to state the power rule. Just like I did yesterday, you don't have to show me this expanded form, but I want you to believe why this works the way it does. So here is an example. So if I have a to the 5th divided by a squared, if I wrote this out in expanded form, what does a to the 5th mean? Cameron? Excellent. So I have a multiplied by itself 5 times. What does a to the 2nd mean? Ada? A times a. So if we DOCF'd, I can divide out an a from the numerator and the denominator. I can divide out another a from the numerator and the denominator. How can I write what's left as using an exponent? In exponential form. How can I write what's left using an exponent? Amanda? A to the 3rd over 1. And we can drop the over 1, but I like that you said a to the 3rd over 1. All right, so what that means is a to the 5th divided by a squared is equal to a to the 3rd over 1. What did we do with our exponents? What did we do with our base? What did we do with our exponents? To get from here to here. What did we do with our base? What did we do with our exponents? Ada? No. I don't want to know what I did in expanded form. Tell me what the rule might look like. If I was writing my rule, what would the rule look like? What did I do with my, put your hands down. What did I do with my base? Yes. What would you say is my rule? What would I say is my rule? So my rule up here was, put your hands down. My rule up here when we did this one, remember we did this one yesterday, right? All right. We decided that instead of writing out all that expanded form, we came up with a rule that said we keep our base and we add the exponents. That's the rule we came up with, right? Okay, so I want you to keep that in mind as you tell me what would you say is mathematically what I did here to get from a to the 5th divided by a squared, and I got a to the 3 over 1. Put your hands down. Ada is doing this for the 4th time. Where did we keep our base? So we keep our base in the numerator. Keep base in numerator only. So we keep the base in the numerator only. And what did we do with our exponents, Ada? What did we do with our exponents? How can we use 5 and 2 to get 3? Patrick, sit up. We subtract them, right? Does that make sense? We could do 5 minus 2, and it gets me my 3. How many of you guys saw that mathematically? I do agree that we divided out common factors. But instead of writing this out in expanded form, I don't want to have to do that every time. Because if I gave you one that said a to the 25th divided by a to the 13th, you don't want to have to write them out in expanded form every time. We need a rule that makes it easier. All right, so we keep the base in the numerator only, and then we subtract the exponents. And it's always going to be your numerator exponent minus your denominator exponent. It's not going to be the bigger minus the smaller every time. For tonight's homework, it will be the numerator and the numerator exponent will always be bigger. But that won't always be the case. So on Friday, we will do different ones where they aren't always, the numerator one's not always the biggest. Okay? So it's your numerator exponent minus your denominator exponent. So if I was to write this power rule, I'm going to write it right here. So a to the m divided by a to the n is equal to a to the m minus n over 1. We keep the base in the numerator. We subtract the exponents. Now you don't have to show over 1 if you don't want to. But I need you to understand that is what we did. It is over 1. It's left in the numerator only. Yes? No, because this is how it works. However many however many of the variables or numbers we have in the denominator, we have a certain number of them in my numerator as well. So we divide out all of them we can. We are combining them all to be up in the numerator. Okay? Yes. No, you're using the power rules. None of this should be using expanded form. You're just using the power rules. I just need you to know why they are the way they are, where these rules come from. All right, so let's practice a couple of these. All right, so I want you to simplify. You're always using the power rules, unless I say to you using expanded form. Otherwise, you're always using these power rules. So if I have 0.7 to the 6th power divided by 0.7 to the 2nd power. All right, I have the same base, it's 0.7. So I'm keeping the base up in the numerator. Again, these parentheses are not necessary. If that was a negative 0.7, they are necessary to make sure you know that base is the negative 0.7. Here, it's not necessary. It just helps you see the separation between the base and the exponent. All right, so I'm keeping that in my numerator. If you want to write over 1, you can. If you don't want to, you don't have to. And then what do I do with my exponents? Alex? So what's that going to look like here? 6 minus 2. So I have 0.7 to the, Alex, 4th power. All right. All right, technically, for us to simplify that, we need to do that math. So we need to do 0.7 times 0.7, which gives me 0.49. And then we would do 0.49 times 0.49, because I have 4 of those. All right. When I do that, did you guys lose a calculator? Anybody? I found this in a desk. In that desk where Alex is. Just saying. So if I do that math, we should end up getting 0.2401. All right, let me give you another one. I want you to find the quotient. Write answer using exponents. Let's do 10 to the 11th divided by 10 to the 7th. AJ, tell me what to do. Which gives me 10 to the what? 10 to the 4th. How many of you guys are cool? All right, let me give you guys another one. I want you to simplify. So let's do 12n to the 5th divided by 8n squared. All right, this one's different because now we have numbers in there. All right, so you're going to simplify the fraction. Improper fraction if necessary. And then you're going to simplify the variables. All right, so I have 12n to the 5th divided by 8n squared. I just rewrote that. I can divide out common factors. 8 and 12 have a common factor of 4. So my 8 becomes a 2. My 12 becomes a 3. All right, so I end up with 3. Well, now I'm going to do my numerator, or my variables. I'm going to have my n in the numerator only, n to the 5 minus 2. And then in my denominator, I still have left that 2. So I simplified the fraction part of this, the numbers part. And then I did my exponent part. I'm dividing in n to the 5th divided by n squared. So I keep the n, the base, in the numerator only, and I show subtracting my exponents. So this would simply be 3n to the 3rd over 2. Questions on that? All right, let me give you another one to do. These are ones that I like to do. This is when I start getting complicated on them. Follow your power rules. This is when I like to, the more of these we do, the harder these are going to get. Hard only in that it's more complicated. You guys can do all these. I know you can, because you just take one power rule at a time. Okay, so let's do another one. I want you to simplify. 3m to the 5th, n to the 3rd, m squared, divided by 6m to the 3rd. All right, so first of all, simplify the numerator. There's several different ways that you could start this. I'm going to give you the way I feel is best. Simplify that numerator first. Don't do anything else. What do I need to do to simplify that numerator? So I'm combining the two power rules together in this. All right, so what do I have to do to simplify that numerator? Cameron? Excellent. So I'm just going to move those m's next to each other. All right, so then I have 3m to the 5 plus 2 times n to the 3rd over 6m to the 3rd. So now I have 3m to the 7th n to the 3rd over 6m to the 3rd. So here is step 1. All right, step 2, now simplify between the numerator and denominator. So here is step 2. So all of you finish that off. So I should be able to divide out common factors between the 3 and the 6. The 3 becomes a 1, the 6 becomes a 2. I have these m's that I can simplify. So I should have, if you want to show the 1 there, you can. You don't have to. So m to the 7 minus 3 times n to the 3rd divided by 2. So I end up with m to the 4th, thank you, sweetie, m to the 4th, n to the 3rd divided by 2. How many of you guys got that? Questions on that? These are the ones that I like, that you have several power rules that you have to use one at a time. And I highly recommend you do one thing at a time. Alex. I just said to you, if you want to do the 1, you can put the 1 there, but the 1 is not necessary. But if you want to put the 1 there, that's fine. You guys cool? Okay, you guys can go. If you guys hear of anyone missing a calculator,